Good afternoon, everyone. Welcome to the fourth webinar for today for what's new in TopSolid 7.16. My name is Bill Gentz. I'm the Sales and Technical Director here at TopSolid USA, and I'm joined by Joe Hart, our Technical Manager, and Mike Kay, our Sales Manager. They'll be fielding questions from you guys throughout the presentation. All right, so the last presentation of the day here, this is all about what's new in 4 and 5-axis milling. Without further ado, let's dive right in. Okay, so not a huge list, but I think it's a pretty awesome list. So first off, let's go into here. So for those of you familiar with our 4 and 5-axis toolpath, you also know that in these toolpaths you have the ability to play around with security shapes. And sometimes the working with those security shapes can be a little challenging because you got to set them up operation by operation. It can be a little cumbersome. So what we did is we simplified it for you. So right here you have a part security shape icon in the equipment tab. It's also right here in case you're a pull-down menu guy. And in here you can globally set for the document your various security shapes. So for example, you have your security block. If you click on here, it'll preview the automatic one. Of course, you can set it to be whatever you want it to be, or you can go to manual mode and type in the coordinates or the sizes you want for yours. So if I said -50 and I go 50, -50, and I know it's exciting to watch someone type in information, and I say 100, get the idea, 0, and then you can start setting what you want, okay? If we go look at the security cylinder, there's your cylinder. If we go look at your sphere, there's your sphere, so forth. Now, what's nice about that then is if you go into any operation, for example, sweeping under multi-axis, and I go to my clearance shape, you can now use the global objects, or you can still create your local objects. Okay? So the idea here is just to simplify things, and if you're using like a global cylinder or a global sphere, for example, and you use global on all your operations, and you want to tweak those rapid planes, you can go tweak them in one place, and then it updates all the operations. All right, so you can see those rapids are following that spherical global security shape. Just a nicer way to control your rapids in 5-axis, for example. Ready. And on to the next one. Oh, you know what? I didn't point this out. Sorry. I'm going to point this out. A couple more points here. All of your security shapes are located in your machine part security shapes folder in the entities tree. So if you want to actually see them, you can turn them all on, or just turn on the one, turn on the other, or so forth, so on, so that you can leave it visible while you're setting up other options. Okay? Perfect. All right. This one we talked about already in 3D, but I'll talk about it again in 5D. For example, you have a 5-axis contouring toolpath, which just like we saw in sweeping, you can trim to the stock. Okay, so 5-axis sweeping, 5-axis contouring, you can trim to the current stock to optimize the toolpath to get rid of any ear cuts that might be there based on the material that has been left. Alrighty, next we have an approach and retract curve and incremental curve. Okay, so first of all, we're going to talk about the approach and retract curve. So here we have some kind of port, right? And in this port, if I run the simulation, let's let this hop right in. You're going to see, let me slow this down, you're going to see that the lead-in is following my curve. Okay? And it's following my back point there as a secondary. Then it's going to project onto the surface to start the actual machining. So you can really control the lead-in and lead-out of a toolpath like this. And to talk about what it's about, you go into here, or how to do it, I should say. You go into settings, you go to plunge retract, you have a approach retract option here. simply select your profile, you set up the rest of your operation like you normally would, and TopSolid does everything else for you. On top of that, you have another method, and I think we showed off in this one, albeit it's a little silly. So you have another type of control, okay, where you can choose your approach retract curve. All right, so here the tool is approaching and retracting following this curve. If we simulate that, again, I think this is a silly sample, but you're seeing it's following the crazy curve down, and then it's doing its machining, and then it will leave following the crazy curve. Another option you have would be on something like this, and you see how my lead-ins and lead-outs are kind of crazy? It's because we're using these profiles here as the shape to use. And these are incremental curves. So my approach curve is my little zebra over here, and my retract curve is this arc. Okay? And it's just to show you that you can do some creative things with your lead and lead outs to do crazy things. If you just need them to lead in and lead out following some kind of path, they don't necessarily have to be anywhere on the part. We will adapt them to wherever the tool path leads in and leads out. That's what an incremental curve is for. And otherwise, if you need it to be in more control, then you use the approach retract. Righty. Next, this one may be the coolest new feature this year. People often ask me, what's my favorite? This might be my favorite. Okay, so what we have here is a new algorithm called 5-axis deburr. Some of you may be familiar with the breaking edges command that's done in 2.5 axis here. This is a fantastic tool, right? Imagine that, but in 5 axis, because that's really what it is. This tool path, if we go into a deburring tool path, so it's right here, we go to our tool selection, you can see the types of tools it supports. So it's quite a variety of different types of tools that you can use. Okay? But just to give you an idea of what you can expect to see here, I'm going to simulate a few of these and then we'll go through these manually. So here I'm just doing a standard little simple breaking edge, right? And I'm using my security cylinder and everything, and this one's just a simple vertical one. Not very exciting. This next one, if we notice, is tilting at a specific angle. So I can specify a specific angle, come in here, and break some edges. Something cooler that can happen there too. This one now is going in full 5-axis continuous to do that inside profile while I'm maintaining an angular, or a range between angles that it can swing. And then this one, for example, is kind of an automatic attempt. It's just going to go after everything. And here you can see I'm using a lollipop cutter. And what's interesting as this goes around is you'll see it reach through the part, under the part. It's actually pretty neat. So here we're getting that area. Come around, get that area. I think this is wild. It's reaching through to get that feature because it can. And so on. And then lastly, you don't have to use a ball end mill or chamfer mill. You can use any old end mill. Okay? So for example, in this one, I'm using a tapered end mill. Okay? Let's let this thing come in here. And we're going to use the side of the cutter to add the chamfer. And when I mean the side of the cutter, I mean the side of the cutter. Nice and easy. Now, that's a simulation. So now why don't I show you how to create all of this. Let's delete all that. And we're just going to start at the beginning. Okay? So I'm going to start here. I'm just going to do that simple one up here just to set the ground rules of how things work. So I'm going to go to deburring. I'm going to go pick a tool. It's going to be my ball nose end mill for now. That's fine. We're going to go select some geometry, and we're going to keep it nice and simple right now. I'm going to select this one and this one. We're going to go to multi-axis, and I'm going to say fixed direction, and that's it. Okay. I should point out, I'm just using the default values. We're putting a 30 thousandths edge break on the part. Okay. So, if I run that simulation, this is that first one we saw where it comes in and it literally just breaks the edge, right? Perfect. Do the next one. Great. Now, I want to do another one. So let's go do the next one. And this next one, I'm going to come here and again, I'm going to do deburring. Same tool, same settings. This time, however, I'm going to choose that path and that profile. And here, again, I'm going to choose fixed direction. And that's not going to make any sense because, well, this top one makes sense because the tool's vertical, right? What's going to happen with this side? Watch the simulation and find out. So the first one is as you'd expect, right? This next one, well, wait a minute. It auto-tilted because it detected a collision. So it's smarter than us and it said, okay, well, you want to break that edge? That's fine. I have to tilt the tool to do it. So that's pretty awesome. So I see a question there. In my opinion, what tool does the 5-axis deburring tool like to use the most based off of what you programmed with it? Honestly, any of the tools that are supported, it works fabulously with. So you could use a ball, you can use a lollipop, you can use a tapered mill, you can use a chamfer mill, you can use any of those tool types to get the job done. Now, going back to the controls, let's say in this case, we don't want to use simultaneous 5-axis on here. We want to get this edge and this edge, but we just want to fix the tilt direction. Okay, so it's real simple. We'll go to your multi-axis, and right here, where it says main direction, because I don't have a edge of the model I can use, I'm going to choose axis by 2 points, and I'm going to say, you know what? That'll be close enough for me. That's the direction I want to tilt. I click OK. You're going to see everything updates. And again, when we simulate, now we're there. And now we're here, again, with that fixed angle. And I should, by the way, do it this way too, just to show the end result. So it's making a really nice, clean chamfer. All right, so far so good. Now let's talk about the next type, which is called deburring normal to contour. All right, so I'm going to flip over to here. I'm going to right click. I'm going to go over here to deburring. We'll pick our geometry. Grab that loop there. Okay. We'll go into multi-axis, and here we want to stay normal to contour. And just right off the get-go, let's just let it do its thing, and let's see what happens. Okay. And if we run the simulation on this, you're going to see, well, because I didn't give it any restrictions, it's rotating all over the place, right? Maybe this one would be fun to have the whole machine turned on for us. So let's turn the whole machine on. Obviously, the link movement has to be adjusted, but you all know you can do that. Right here, oh, that's horrible. Bang, 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 bang. Right? So, how do we resolve this? Well, you resolve this by setting an angular limitation. So let's go back in there, go to multi-axis, and we're going to set tilting restrictions of between 40 and 80 degrees. And then if we watch the simulation again, this time, it doesn't rotate so far. Nice and clean. Okie dokie. So, next, how can you select geometries? So there's different ways of selecting geometry. So far you've seen me select them manually. So let's use a little bit of automatic selection. We'll use some filtering. So we'll go to deburring, okay? And maybe on this one, let's change our tool just to be different. I'll use my lollipop cutter, okay? And when we go to geometry, in this case, I'm going to set some altitudes, okay? So I'm going to say that my minimal face, or minimal value of that face, to the minimal value of this face are going to be the ranges that I want to work to. And I'm going to hit the plus sign here to find all those edges. And you can see it finds all the edges that fall within that. If I change my minimal to be maybe this face and recalculate, now it finds just those edges. And then if we go into multi-axis, because we know we'll have to set the limitation angle, we're going to say a max of 75. Okay, you can leave it at 0, that's fine. And if we watch the simulation, it's going to do its thing. And you can see how nice these moves are. It retracts to a safe place. It's always getting to where it needs to be safely. Pretty nice. All right, final one. I'm going to do one last one, and this time when we deburr, I'm going to use a different type of tool altogether. In this case, it's going to be a tapered end mill, okay? And for my tapered end mill, really the only thing I'm going to do, I'm going to go set some geometries, right? So I'll select this one and maybe this one just for fun. And then under multi-axis, I'm going to set how far I want the tool to stick out past the bottom. That's it. And now when we watch that simulation, and I'm going to do it without the machine because I want to point out something here. Let this thing get up close. So here we go. Slow this down some. Now we're getting into our lead in. Look at that. I mean, it is really checking itself nicely. John, I don't know. I haven't checked it on a chamfered face yet. To me, I think this is like the breaking edges command, and as you know, the breaking edges command works best just on a hard edge of the model. So my thought is that is likely going to be the case with this as well. Okay? But if you got to do a lot of breaking of edges on parts, and they're crazy parts, I think this is a module worth getting. This is a add-on module. It's part of the multi-axis pocketing module. Okay? Alrighty, here we go. Let's keep on going. Speaking of multi-axis pocketing, alrighty. So, next thing we're going to talk about is multi-axis pocketing. If you guys recall, we introduced this module. It's a modular works function, so is the multi-axis chamfer. We introduced this last year. Okay, we've added functionality for module to this. Let me just turn this off for the moment. So, at the end of the day, multi-axis pocketing can be used to finish or to rough out a part where the pocket is not flat, right? Well, now we're including the ability to do side finishing automatically and then finishing to the floor automatically. Okay? And in this case, when we're finishing the side walls, and we're going to go ahead and try to do this live. So if I go in here and go down to other and go down to multi-axis pocketing, let's change over to side finishing, right? I believe we're going to use tool 1, perfect. Let's go pick our geometries. So the bottom faces are the faces we don't want to machine, like so. The lateral faces are the faces we do want to machine. We go into our settings, right? And we're trying to finish. So Let's do this as a morphine. Let's do this with automatic guide curve mode. And let's do this as spiral. Okay. And then let's say that's good. Let's just see what happens. Now, it's going to take a sec to calculate, but what you're going to see is that it's going to create toolpath to machine that non-uniform sidewall of that multi-axis pocket. Okay? What's interesting about it is it does a lot of the heavy lifting for you. Okay? Yes, it takes a minute to calculate, even on my computer. All right, good, we're done. So now if we look at this toolpath doesn't look like the toolpath I had. You know, this one that I showed before, right? And why doesn't it look like that? Well, there's other options we have to take into consideration. Okay? And let me go open something up here. Right, if I go into my operation here, and we go to multi-axis, and we go to tool axis control, you have here something called tool contact point control. Okay? I'm going to bring a picture over to kind of understand. 0, if I set a target of 0%, that's the tip of your tool. Okay? 100% would be the full diameter of the tool in this case. So what we're trying to do is we want to cut with the sweet spot of the tool right here, right? So 40 to maybe 85%, and I want my target to be 85. So I'm going to say 85 and 85, and we'll click OK, and then we'll see if we get a better result. Okay? This is definitely something you got to play around with a little bit to understand. But you're going to see right away that's significantly nicer toolpath, right? And if I go activate that cut that I had up before, lovely, oops. Activate. And we go back and edit this operation. And let's go look at this right on from the front, shall we? Put our tool on. You can see, as I drag down the tool here, you can see it's staying at that 85% of the side of the cutter. Okay. Alrighty, cool. Any questions on that one? There's a couple of other options available with this. If you guys wind up looking at the module or you want to look into the module, we can go more into details about what it has, but you have a nice side finishing command now and bottom finishing command. All right, I think there's one last one, and this is port machining. So this is also a Module Works command. I don't remember, I know this is a add-on module. I don't remember if it's part of the multi-axis pocketing or not. So if this is something you're interested in, then we have to, I'll have to let you know what the cost is involved with that and how it's packaged, okay? But at the end of the day, it's a really, really slick module for port machining. You really have nothing to do other than load your part on the machine. Let me show you what I mean. If I go into roughing, okay, or just, let me back up a sec here. Port machining is here. Okay, so if I go into the port machining command, you'll see first of all that we have different strategies. I'll zoom up on here. So you have roughing, you have finishing radially, you have finishing longitudinally, and then you even have a rest machining command. So you can really do some crazy stuff in here. But where the meat and potatoes are of the settings are under geometry, actually. So your selection mode is how it's driving down the center. Okay, so you can choose your own guide curve or let it create its own. So far, all the tests I've done, it creates beautiful guide curves. And then the limitation, do we want the strategy to machine only from one direction as far as the tool can reach? Only from the other direction as far as the tool can reach? Or from both directions as far as the tool can reach? Why not? Okay. And now for the limitation, do we want the minimal, maximal, so forth? You get the idea. Okay. Then of course you have your standard toolpath settings where you set your step overs, how you plunge and retract and all that kind of fun stuff. But if we watch the simulation of this, and let's see, we watch this in Verify. Let me turn on the whole tool, sorry. Silly me. There you go. So it's going to do a really nice job. It works from the middle in. Let me go to this mode. There we go. You can see now it's starting to tilt as it's going. So it's really taking care of everything for you automatically. Okay? And then once it gets as far as it can reach on this side, it's going to automatically retract and come out to the other side. Like so. And start machining over there. Okay? Now, just like the roughing, the finishing, again, a similar command. It's just finishing toolpaths instead, right? So you have your standard finishing toolpath strategies, but most importantly under geometries, again, you're coming from both directions, the limitation, how it's being defined, and then you can even play around with the top and bottom areas where you can drag the starting, the ending position of the tool a little bit to tweak your toolpath. Okay? All right, so I see a comment in there. The integration of module works toolpaths appear to be much better in TopSolid and other CAM systems. Well, thank you for that. My opinion is it looks better because TopSolid 7 is just a cleaner interface than most systems. Okay, you have your modern interface, you have your modern platform, so maybe the integration works more smoothly because of it. Cool. All right, guys, so that's the end of the major improvements for 4 and 5 axis continuous. Make it official here. The next webinar doesn't start till tomorrow at 9 a.m. where we'll be going over turning features. And there's some pretty exciting new features coming in turning for this year. So be sure to log in tomorrow at 9 a.m. Central. Anyone else have any questions or comments on the multi-axis improvements? Feel free to type them into the question area and we'll try to answer a few of them before we call it finished. No? All right. Well, if you have a 5-axis machine, you should buy the 5-axis edge braking because it's just awesome. All right. Have a great evening, guys, and we'll talk to you tomorrow.